Welcome to The Explainer. Today, we're diving into a really cool experiment that might just hold the secret to building AI that's not just smart, but truly intelligent. We're going to explore what separates a simple program from a system that can actually adapt and organize itself.
It's a great question, right? And it often boils down to one critical skill: the ability to not just learn a task, but to actually learn how to learn, to adapt and organize itself from the ground up with no one telling it what to do.
So, to put this to the test, researchers set up a kind of digital arena. They pitted two AI systems against each other, Sim2 versus Sim3. Now, on the surface, they look pretty similar, but as we'll see, a few key differences in their design led to some wildly different results.
Okay, so let's get into it. We're going to break down this tale of two systems, this battle between chaos and intelligence. We'll go round by round to see exactly how one system can evolve from just a bunch of random actions into something that shows real sparks of genuine intelligence.
First things first, the most basic test of all: can you even survive? Researchers looked at something they call the global thermobudget. Just think of it like a company's bottom line. Is the system spending more energy than it's bringing in, or is it actually building a surplus and turning a profit? And wow, the results could not be clearer. Sim2 is constantly in the red. Its costs are always higher than its savings, meaning it's bleeding energy. But then look at Sim3. It's not just getting by, it is thriving, consistently building a positive energy balance. It's profitable. What this tells us is that right from the get-go, only one of these systems was ever built to last. Sim2's entire design was fundamentally unsustainable. It was on a path to self-destruction. Meanwhile, Sim3's setup put it on a clear path to success from day one. Okay, so survival is one thing, but a system doesn't just need to survive. It has to get better, right? It has to learn and maximize its rewards. So how did our two AIs stack up when it came to their learning curve? Again, the difference is just night and day. Sim2's learning is all over the place. It's erratic, inefficient, and it really struggles to adapt. But Sim3? Its learning curve is high and stable. That's a sure sign that its reinforcement learning is dialed in. And importantly, its different parts are starting to work together. And listen, we're not talking about some tiny little improvement here. The technical report found that Sim3's learning was a staggering 300% more stable than Sim2's. That is a massive, massive performance gap. Okay, but this next part, this is where things get really fascinating. Surviving is great. Learning is even better. But the real magic, the true leap, happens when a system starts to organize itself without any top-down instructions. So to get what's happening here, we need to talk about a key concept: emergence. It's when you get complex, super coordinated group behavior that comes from very simple individual actions. The classic example is a flock of birds, right? There's no leader bird telling everyone where to go, just collective, bottom-up intelligence. So, did either of our AIs show this? Well, for Sim2, the answer is a hard no. The whole time, its individual parts just acted like a disorganized crowd. There was no teamwork, no coordination, just chaos. But Sim3? Oh, Sim3 was a whole different story. Something incredible started to happen. Its components began to group together, forming these concentrated clusters. They were basically forming teams, working together to solve problems way more effectively than any of them could on their own. This was such a big deal that the researchers themselves called it a fundamental shift. This was the exact moment the system crossed this invisible line, evolving from just a random collection of parts into a truly organized, coordinated whole.
So how in the world did Sim3 pull this off? What was its secret sauce? Well, the answer, it turns out, is in how it learned to adjust its own goals over time.
The whole story is right here in the data. Sim2 is constantly making these spiky, chaotic adjustments. It's like it's always in a state of panic. Sim3, on the other hand, is calm, cool, and collected. It makes fewer, smoother changes, which is a huge sign that it's learned to be strategic instead of just reactive. And this strategic thinking goes all the way down to the individual parts. Sim3's components learn with this smooth, rhythmic pulse. This is actually a classic sign of successful meta-learning, of learning how to learn. It nails that perfect balance between exploring for new, better ideas and exploiting the stuff that it already knows works. So let's wrap this all up. What does Sim3's big win actually teach us?
Well, it's not a fluke. It's basically a blueprint for how we can design the next generation of truly adaptive intelligent systems.
It really boils down to this 4-part playbook. 1. Build for sustainability from the start. A positive energy balance is a must. 2. Design systems where working together actually pays off. 3. Favor calm, strategic adjustments over panicked, reactive ones. And 4. Nurture a stable learning rhythm that perfectly balances exploration and exploitation.
But here's the real kicker. It's not just one of these things. The researchers concluded that the true magic is in the synergy. It's the combination of all these factors working together that allows this incredible emergent intelligence to finally blossom.
And that really leaves us with a final, pretty mind-bending thought. We're moving away from a world where we just program systems to do a task, and we're entering a world where we design systems that can figure out for themselves the best way to work together. And the implications of that, well, they're going to be profound.